afternoon, everyone. So sorry, I think I woke up somebody. Good afternoon. I'm hoping that you are enjoying this conference. It's wonderful to be back together. So thank you for having me. Came from Canada. My name is Pierre. I'm a senior cloud advocate with Microsoft. And you might want to ask, what the hell is that? So my role is twofold. Number one, I'm the advocate for the community with our engineering. So when you have feedback, you have this scenario doesn't work in real life, your documentation sucks, you tell me or my team, and then we go back to engineering and say, Bob said that your documentation sucks, so fix it. The other part of my job is then they fix it and they come up with a brand new feature and a brand new service, and then we figure out what the value of that is, and then we come and tell you guys. So that's my job, best job in the world. But today, I want to talk about something that happened to me not too long ago. I was preparing for a big presentation with a very large customer, which will remain nameless because of NDA agreements that we've signed. And the person that was presenting before me, because we're all on the same team, we're using the same subscription, at the end of their session, between the breaks, they ran their cleanup script and shut down all of my machines that I needed for the presentation. And of course, that only happens when you need to have a machine run for like hours to collect data, and then somebody shuts it off. So I was feeling very miffed. And we did have scripts that were running on schedules to turn on and turn off our environments because it is cloud. And cloud, you pay for what you use when you use it. So if you shut that down, no pay. And I do have a budget, even though I work for Microsoft. And we had scripts to start it up, but they were manual, because you never know when you're going to need a specific demo environment. So we decided to figure out a way that we can trigger all of those things and protect ourselves from having systems that were down. And this is what we're going to talk about today. And thank you, first of all, to the sponsors for making this possible. So I was feeling very triggered and decided to look at it. So I figured out the problem. So the problem are that, in our case, we had large scripts that were fairly problematic, because if some one person changed one thing, could end up breaking 15 things. And when you're looking at hundreds of lines of code, and you're looking for that missing comma, not easy to find sometimes. So our large scripts were problematic. So how did we fix that? Executing scripts at the appropriate time, it has blind spots. I understand that task scheduler and cron jobs have a place in this world. In my heart, that place should be behind the shed, because I hate them. I hate them with a passion. I've always believed that automation should occur in response to an event, not in response to a clock. So it has blind spots. It's significantly more difficult to pass dynamic parameters to a scheduled task than it is to a triggered task. Because there's ways of doing it, like change a system variable, and then when your script runs, it actually looks at that variable. It can be done, but it's not straightforward. And script polling is inefficient. And that one, I want to know in this room if anybody does this, because that was eye-opening. And not in a good way. I have a customer that runs two VMs in the cloud, one per region, that runs 24 hours a day, 7 days a week. And on that server, they run PowerShell scripts that run, go to sleep, then calls itself and runs again 24 hours a day. Anybody else does that here? Good, because I was going to ask you to leave. They call it script polling, where the script runs and it just keeps polling to see if there's anything new they need to do. Do I have to check something? Do I have to check something? Do I have to check something? You're in the cloud, so now you're paying VMs. That'd be they're not huge VMs, but you're still paying money to run something that does not need to run. You have management headache because now you have to patch those VMs that are running. You have to secure them. You have to, if you're connecting to them, are you connecting to them over SSH, RDP? That opens security holes. Your security team is not happy. There must be a better way. Oh, and did I mention that I hate time scheduler? With a passion. Especially cron, because I can never remember the nomenclature of the cron job. But anyway, I digress. So that's when we looked at triggers for our environment. We took the very large script and we broke it down into pieces that we could trigger. Because this is what we wanted to avoid. I am not a trigger. Well, if you want to pay me the amount of money Microsoft is paying me just to sit there and hit a button, I will. But not something that we want to do on a regular basis. So we decided to go serverless. We don't want to manage that machine. We don't want to patch it. We want nothing to do with the networking behind it. I just want it to run. Because I'm a lazy admin. I admit it. If I don't have to do something, I won't. So we decided to use serverless. Serverless is great for a few things. Stateless. So you don't end up with the garbage from the last run or the last execution to pollute the next one. There's no temp files. There's no nothing that goes and kind of rear its ugly head and bites you. It is task-based, and it can be scheduled. Just saying. And it may be built on containers. So that's the nice thing. It runs, it disappears, you're done. So we looked at Azure Functions because we knew that we can react to an event. In our case, we decided to check the power state of each VM in our environment. So if one machine changes their power state, it triggers the script that does an inventory of all of our machine, passes that inventory to the next script, which then individually looks at all of these machines and sees whether or not they need to be on or off. If they need to be off and they're still off, then script's over. If they need to be on, are they stopped or are they deallocated? Two different processes. Well, you can do the same process, but in this case, we're doing two different processes. Because if it stopped, why did it stop? And when you stop a VM in Azure, you've actually just gone to the machine and went shut down. But Azure is still billing you because the resources, the CPU, the memory, the disks, are still allocated to that VM. Anyway, so we decided to do this and use some of our triggers. In this case, we use the event grid triggers. That trigger now brings in a function, and this is not what we would call a PowerShell function. However, when you have a long PowerShell script, and I've seen so many that are like 30 functions, and then the main body of the script is like 10 lines. Because all you do is you call functions. You can do this here in PowerShell, C#, F#, Node, Java, whatever your scripting language of choice is. I assume, because we're here, that we're talking PowerShell. Am I correct? Okay. And of course, you can send the results of any of your processing somewhere else to be handled by another process or another script, or maybe it's just for logging. because I really want to know who the hell shut down my machine half an hour before my presentation. But that wasn't logged. Now it will be. We also have Logic Apps that was an option, and we are using a combination of both in this situation. The point of this session is not necessarily to go deep into functions and Logic App. I want you to think going forward, if you have new scripts that you need to create. I would never tell you to rip and replace. I don't have a sales quota, I don't care. But if you have something new coming, start thinking about turning your scripts into microservices. Small, task-based, 10, 20 lines, whatever it takes, and then use the triggers that are built in to start them, to pass information along in order to do what you need done in a very easy way. Logic App brings us hundreds of trigger, but also connectors. So that once you've processed the data, you want to decide, what do I do with this? I've got a list of machines. I know which ones have been turned off. I know which ones have been rebooted or restarted. What happens typically in your environment is you have an alert. And we love alerts. We love alerts so much that on Monday morning you get to your office and you've got like 57 alerts in your inbox. The first week you go through them all. The second week you go, oh yeah, I saw that, never mind. No. The third week you're just going to Control A, delete. The fourth week you make a rule, because we're lazy, to make a rule to delete the alerts. And then something really happens and you don't know about it. So we have to address the noise that the alerts will do us. So Logic App, because of those connectors, I can decide, is this something I want to pepper spray my email across the entire IT department? Or do I just want to put a note in the Teams channel, or in the Slack channel, or in the whatever channel you're using as a team? So that's what we use that. Containerized, rehostable, stateless run flow again. I love the new VS Code extension, but I know that this is a VS Code versus ISC apparently, and this crowd is a touchy subject, so I'm not going to go there. And the benefits of doing that is that it gives you a lot of flexibility. So if we're looking at Logic App, functions. So these are a small portion of the list of the triggers that are available out of the box. And where is he? Is he here? No, he's here. There was a session earlier this week on making your own triggers, on making your own bindings. If you haven't seen it, when it comes online, go check it out. It's really cool because you can create your own bindings, your own triggers, if essentially, if one of those doesn't meet your match. And if we're looking at, I was going to list them, but then the font got really, really, really small. So this is just a recording of the screen when you're looking at all of the connectors and triggers in Logic Apps. And I'm not going to wait until it's finished, because if you're seeing at the top there, I've got my little track bar that is very small and going down the list fairly slowly. So these are the amount of interaction and the amount of integration that you can have with other products. To start your script, to respond, to send data out. So when we're looking at our scripts and thinking about them in terms of microservice, take advantage of all of these parts that are already built in for you. It really doesn't make sense to reinvent the wheel every time, unless what you're trying to do is become, what's the word? Indispensable. So they can't fire you, because then nobody will know how to run things. Like I have a friend that used to do a network, and he would take the patch panel, put it upside down, patch all the wires, and then flip it so that nobody else really would look at the wires and know exactly what the order of the... So he figured, they'll never fire me, they'll never be able to rewire this building. He was wrong. They're task-based, I mentioned that already, which is great. They're extendable, meaning all of those tools that were flying by the screen can be added and extend the capabilities of your PowerShell script. So if your script doesn't do one thing, you don't have to invent it. If there's a module, great. If not, use one of the tools. They are secure, which if you're in an enterprise setting, anybody here works in security? Okay, I got a few hands. So they're secure. When you're running a PowerShell script, yes, it has to be signed, and yes, it has to run in the right context. In this case, we're not just talking about machines being signed. And I'm going to go off script here and go right into a bit of a live demo. If I look at my environment here, and I've got my environment, where is my Logic app? No, my function. There it is. There's a section down here called identity. I can assign a machine-based identity to my function. It essentially gives it a digital tag in AD, and from AD, I can say that that script has access to only demo 1 resource group, only subscription X, is only allowed to read information and not to change anything, like the permission I give my boss because I want him to be able to see my work. I just don't want him to change my work because he's going to break it. So the identity allows me to do that, and it's very simple to do. When you go in, and everything I'm showing you here can also be scripted to be deployed. So I go here and I set my status to on, which means as soon as it turn it on, starts calculating, creates an identity, principal ID, stores that in AD, and then I can assign a role. By scope, so in this case, let's say for the subscription and the role, there are a number of built-in roles, and if one of the built-in roles doesn't suit you, you can make your own. Custom roles are easy to do. It's just a JSON file that says, this is where you're allowed to go, this is what you're allowed to do, this is what you're explicitly denied to do. Import that into the system, and you've got a new role. So in this case, I could say, give the appropriate roles to that function. So for sake of argument, if my function gets compromised, let's say it's a HTTP trigger, so I send a webhook to start my process, somebody steals my key or intercepts it, whatever. Well, now I've at least limited the amount of damage that that script can do. If somebody, let's say, modifies it, because of that, or because of its role assignment of proper role, now I'm okay. I don't have to worry about it. So my security guys really like it. Oh, and no need to retrieve hard code password of any kind. Who here hard codes credentials in scripts? Get out. No, I'm just kidding. We have done a scan, and we do the scan of all public GitHub repos, and I don't know if it's been published, but you would be surprisingly scared by the amount of admin credentials that are hard-coded in scripts and code that is uploaded on GitHub. And we've notified the repo owners, maintainers, and now we track it every month, and it doesn't seem to be going down. So by doing it this way, the function as the identity and as the role, you don't need to log in for it. But there's a way that you can log in for it if you decide to. So let's jump back into a demo. And what I mean, there's a way to log in, so to give the script within the function another identity, is if we go to our functions here, they are 3 application files. It's a little slow. What we have is the host.json, which configures the runtime of the container that's running your script at the time it's running your script. So it's always configured exactly the same. So we tell it which level of debug information that we want to extract from there. We've told it what extension bundle we want to add, which queues, how often are we polling those queues, all of that information, so that the host sets up the container or the VM running your code. The profile, like you would think it's like your profile in PowerShell. So if you want to have like different colors, funny fonts, you can put that in there. It's kind of useless because it runs headless in the cloud with nobody looking at it. But in this one, I can say if there's an environment variable called MSI secret or managed system identity, disable the autosave context and don't connect. And then it connects as the managed identity using the connect AZ account. If you wanted to give that script within a function a specific credentials, this is where you would put it. However, this is the same as hard coding a credentials, so don't do it. If you have to for testing, maybe. In production, never. So that's the second file that we have. The third file is our requirement. Because this runs a vanilla version of PowerShell 7, and it only comes with the out-of-box modules installed. How many of you, raise your hand if you install modules from the gallery on a regular basis? Every one of you. Which means if you're running in an environment that has a server that is a serverless, it's really just somebody else's server, that is instantiated every time from scratch. Now, do I have to go and install my module one by one? Do I have to list them in my code itself? Well, there's a combination. In here, I can say my requirement for this one is the AZ command at the minimum version 7 point whatever. So I want my major version to be 7 and then update itself automatically. And I have the AZ connected machine. And you would think that because it's AZ dot connected machine, that when I say AZ, it would include all of them. That's not the case. So if you're doing a resource graph, you have to add that module. If you're doing connected machines, you have to add that module. So there's some trial and error. So you'll run your script, it'll give you an error saying modules can't be found, blah, blah, blah. So you install it there. Once it's installed there, in the function itself, then you can import it. So it's installed on the server, you can import it in your script. And then we have application keys, which is another layer of security that you have. So you can define a host key that will be across all your functions. You can define a system key, and you can define actual keys for each function. Then we have the functions themselves. So in our case, what we did is we have this script, which is very small. And the point is, I'm not going to show you my PowerShell prowess, because I have none. All of you are better coders than I am. That's not my job anymore, so. But it goes and it checks the resource group and checks all of those machines and gets their power state. And the way it does that normally is I have to shut down or turn on one of the machines. So when it detects a power state change in event grid, and an event grid is basically anything that happens in Azure is written to the grid. Doesn't stay there very long. It flushes as it goes. But everything is written to the grid. You drop a file into a storage account, it's written to the grid. You change a file in a storage account, it's written to the grid. You can use that grid to trigger stuff. In our case, because I don't want to have time to shut down a machine because I'm going to need it in 5 minutes, so I turn this into an HTTP trigger. So if I send that command, so if I triggered it, you've noticed that it's not coming back very quickly. That's our concept of a cold start. Because that machine only runs when it's needed, if it hasn't run in, let's say, the last hour or 2 hours, it actually will unload itself. So I'm not wasting resources because somebody else in the cloud is going to be using those resources. Now the machine started. It went through my requirements list, installed what needed to be installed, ran the script. Now I have my list. So my demo v6 is deallocated, demo 3 is stopped, 1 is deallocated, and 2 is running. Normally, if we go back to our script, if we look at the integrations, when we look at the integrations, it's where we tell it what to take in, what to do with it, and what to put out. So in this case, I'm taking my HTTP request, I'm feeding it into my function, which could be any code that you would run on PowerShell, and then my output, I send it to a storage queues. So queues are also a trigger for the next script down the path. Making sure I'm on time. Okay. For making going down the path. So it goes into a storage queue, and if I go to that storage queue now, it's going to be empty. And the reason it's going to be empty is because the next process has already picked up the message and acted on it. And then it put that information and say which one, and the way it decides if that machine needs to be on or off is because if I go to my demo environment, and if I look at demo 3, for sake of argument, that we know is stopped or was stopped, well now it's not stopped anymore, it's running. My process has figured out, but it also looked at my tags. So I have a policy, we now have a policy in our demo environment to tag our machines with, is it production? Is it demo? Is it testing? Is it I'm screwing around with the technology and I don't know what else to do? Or is it life cycle? Is it persistent? Does it need to be on all the time? Is it non-persistent? Is it ad hoc? We have multiple codes that we use. Typically, we also have a tag for whoever created it so that we can say, you still need that machine because it's costing us a lot of money. Because I've had that conversation with my boss. I was running a demo with G5's machine, a scale set of 100. I forgot to turn it off after my demo. Thank you very much, went home. I think a $96,000 bill 3 weeks later. Policies. It's a good thing. So it checks this, and then it goes all the way through its process. So if I go back to here and I send my request again, I'm going to trigger the exact same process. But now, see how fast it came back? It's because it doesn't have to do a cold start. It's already running. It's already there waiting until it times out. Then we're going to have... So once it's on, it's lightning fast. And my code's not very efficient. I could do it a lot better if I had your help. But now all my machines that need to be on because of their tags have now been turned on. And if everything went according to plan, in my reporting queue, I have action. We restarted, because it was already allocated, so we restarted demo3-VM. Now we jump into Logic Apps. My Logic app picks up that information. Sorry, the screen's a little. Picks up that information, initializes the rules, the alerts, the resource ID. It picks up all the resource ID, splits the list of VM, because right now I only have one, but I could have 20, 30, 50. So it splits that information, parses it. The important part, because that's all easily done in many other ways, the important part is down here. Based on my tag, is it equal to production? Of course, I just messed it up. Is it equal to production? If it's equal to production, then check. No, the first one was if it's turned off or it was an action was done. Is it the production machine? If it's a production machine, then email me, because I want to know. It's urgent. And I'll make sure to remove the rule that deletes the alerts. But if it's not urgent, because it's not a production machine, then I'm just going to post it to our Teams channel. So we've now taken alerts, gave them a way to be processed, because this, now it can be reused. So my scripts to check and restart my machine send the information to that queue, that queue is now looked at by my Logic app. My Logic app is also used in my alerts. So if I go to Log Analytics, where I collect the logs of all my running VMs or all my running systems, whether they're in the cloud or on-prem, because Log Analytics with Azure Arc enabled machine collects all that data from all your machine into one gigantic repository, and you can write your own alerts for it. That alert can also trigger that script. Can also call that Logic app when something happens. So my code is now inherently reusable immediately. So you write one Logic app to decide how you're going to communicate your alerts. You write one script to check the status of your machines. And you just call them when you need to. They're all in the same spot. There's no deployment of it. You can. And of course, all of that can be automated in terms of a CI/CD pipeline so that your code goes into a repo. When you make a change, you pull a pull request, merge to main. I have to reprogram my brain to stop saying the word master. This is our DNI, diversity and inclusion training kicking it. Our main. And once the main is installed, then it would deploy to Azure, to Functions, to Logic App, to anything you want. So, we have our information, we have our script, and we have automated our environment. Two things that are really important. Functions are meant to be ephemeral. There are such a thing as called the durable functions that can last longer. But like the standards functions that you have are meant to run very, very quickly. So if you provide a command that will take some time, such as I start my VM and then I wait for the process to finish so that I can get my JSON to validate whether or not it failed or not, that's not going to work. Your scripts are going to fail every time. So the no wait or run as jobs become critical from PowerShell's point of view within a function. Because you have to tell it, just issue the command and move on. We'll have another function to go check whether or not it came back on time. Very important, because it will fail every time, and the error message is, how should I say, less than helpful. Cold starts, I already talked about this, but I wanted to make sure that it was highlighted. Cold starts do happen, and we do talk about, or I did talk about the fact that our functions run an environment that's instantiated for me when I need it. It stays on for up to 2 hours, I believe. And then if it's not being used within 2 hours, it's shut down. You're only paid when it actually executes, regardless of whether or not it's running for those 2 hours. If you execute it 20 times in that 2 hours, you're going to pay for 20 times. That's it. If you're not executing your functions, you're not paying for that function. So it's also very economical. The only thing you're paying, I believe, is the storage cost of saving your scripts in the cloud. And yes, and I had another demo which I had to remove because the, how can I say that politely? The big brains in Redmond, I believe, changed an API over the weekend. So the demo was fantastic on Friday. And today, I tried it yesterday, and we talked about that. Tried it yesterday, and all it returned me was the opening and closing bracket of the JSON, but nothing in the middle. So I kind of thought maybe it's not worth showing. Here's a nice empty string. So in this case, it does, you can automate through Functions and Logic App workloads that are on-prem. If you have a connected machine using, for example, Azure Arc, then you can use Azure Arc to do stuff. Like Thomas yesterday in one of his demos, he showed that you could SSH to a machine that doesn't have a VPN to Azure through the Azure Arc agent. Kind of the same thing. If you're not connected through an Azure Arc enabled computer, then you need like a site-to-site VPN or some way to get to it. That's just basic networking. We're not going to change that. So, I've got 10 minutes that I left for questions. So thank you very much. If you have to go, go. If not, when I continue conversation, go ahead.
Just to fix this problem that you were speaking of for the VM, you could just make a policy as well, right? That the VM cannot be closed down and tagged as that thing.
So the question is for my original problem, wouldn't it have been just more efficient to make a policy that says that machine can't be turned off if it has a tag? Yes and no. You can create those types of policies. They are very unlikely to function in a production environment because, number one, that machine will need to be rebooted when it's patched or at some point. The system can, because of the 99.99% uptime guarantee, so our SLA, that machine may have to move from one compute unit to another in our data centers. And like one of our data centers, the one I visited, phase one was 10 football fields size. That's phase one. We have now up to phase 4. So that was, if I believe, 5 miles? 8 square kilometers. That's the size of our data center. So it may have to move from pod 1 to pod 255. At that time, it may also have to reboot. So if you have a policy that says my machine can't reboot because of my tag is production, then when an automated process needs to restart it because reason X, now you're a chicken and egg kind of situation. So yes, you can. You have to be very careful with that, is my answer.
So you would not use it in that way?
I would not use it in that way. At this point, all I want to know is there's a change that happened. Did it need to come down? Does it need to stay up? We figured out a way to do this. And then we can log all of that because we can send this to, after the reporting, we can send it to a log file. That should be the number one conversation that you have at the beginning of every project, when you figure out that there's a problem and how we're going to fix it, that should be the number one conversation is, do we need to fix this? Or are we just doing this because it's fun? And if we need to fix it, what's the best way of doing it? Because of course, if all you know is PowerShell, it's going to be a script. If all you have is a hammer, everything is a nail. So that goes into those conversations. Any other questions? Yes?
Is it possible to include Azure Automation for the solution?
Absolutely. The question is, can we include Azure Automation? Absolutely. And Azure Automation is a great way of doing that, and it has very much a lot of the same characteristics. The reason I didn't cover it today is because 30 minutes. Because we could do an entire day of looking at all the ways you can automate everything in Azure. Functions, Power Apps, Logic Apps, Azure Automation, and then there's so many of our partners that integrate. So if you're looking like for configuration management and all of that, we have hundreds of partners that would integrate their automation solution. Like we have 2 partners here that do just that into our solution. So I had to pick a couple. So we looked at Logic App and Functions because in this particular scenario, those are the ones we picked. But automation, absolutely a great way to go about it as well. The problem I had with the automation is that it's not quite as straightforward to add modules to an automation because your platform stays the same. So to add a module or import a module that your script will use is a lot more, I wouldn't say complicated, but problematic in automation than it is in functions. Because in functions, it's just, I do my requirements file and I list it. That's it. It is possible. And I think the last time I looked at it and I talked to the product group about that, they were fixing it. So I haven't looked at it since. Okay, so they ramped up to 7 and they fixed the module. So maybe it's a good time for me to take another look at it. Thank you for that information. Anybody else? Not yet, but I'm planning on putting the code and that presentation PDF format into the repo for the... This was also done very quickly for the PowerShell Summit in the US because Justin and I had basically the same presentation. So I decided to change mine. And that's when Gael asked me if I wanted to come and present it here, which I loved the fact that I can come to Vienna, into your beautiful country, and visit for a week. So thank you. Any questions? Nobody's sleeping, but you're all still here, so that's a good sign. So thank you very much for your attention. My name is Pierre Roman. I can be found on Twitter at Wired Canuck. And if you need to contact me at work because you have feedback about our wonderful product and you want to help me be your advocate, I don't put my email up anymore because that gets harvested as well. But it's first name dot last name at Microsoft.com. And with that being said, thank you very much.